Hi guys, my name is Zina Bloraki. I also go by Z. I want to start by saying thank you guys all for being here. I'm really excited to share with you guys Agile AI and best practices from chatbots all the way to computer vision. So to start, we will be talking about some forward-looking products, so just keep that in mind when you're making your purchases decisions. So what are we going to cover today? I'll go over briefly the building blocks, so Einstein Vision and language, and how those are being incorporated in all of our different products. And then we'll look at Agile AI, and really how do you iterate to success? Then we'll look at best practices, so we'll look at the different steps to build your models, and I'll provide tips and tricks for each one of those steps. And then we'll finish off with what's new and some use cases on the latest things that we're announcing at Dreamforce this week. And then if we have some time, we'll do some Q&A. There's a mic up here, so hold questions for the end. Cool. So maybe just before we start off, let me just give you guys a little bit of background. So I'm the product owner for Einstein Vision and language, and my team is part of the Salesforce Research team. And so half my team is literally advancing the state of the art in AI. They're writing papers, talking at conferences. A few months ago, for example, we just released the biggest language model in the world, so really just pushing the boundaries of what's being done in the AI space. Then the other part of my team is the applied research team, and we focus on really building AI for CRM. So integrating with the Salesforce platform and really bringing value add to our customers. So really closing that gap between the latest and greatest and value add to our customers. And then, of course, all of this is done on the trusted platform, Salesforce platform. So just to give you guys a little bit of background of how we work, ideas can kind of come from anywhere. And a lot of the products I'll talk to you guys about today actually came from customers. Customers came to us and were like, hey, we have this use case. Can you help us solve it? And so at that point, we go to our applied research team, and we're like, hey, we're hearing from our customers that we have this pain point that we want to solve. Can we do this better than what's out there in the market? And so they then go and play around, look at all the data, and see if we can build models specifically for our CRM use cases. Once we've validated that that's the case, that we actually can do better than what's out there, we then work with our engineering team. And that's actually a lot of hard work that goes into there, like with our infrastructure, basically deploying and scaling these models, and making sure that they uphold the trust and security standards that we have here at Salesforce. So a big chunk of the work actually goes into the engineering of these models. And so with that, I'm going to go ahead and talk to you about some of the products that we have available to you guys. And really what we do with these products, I'll talk about Einstein Vision and language. We make it very easy for you to train your own models, right? We simplified it so you don't have to worry about the deep learning models that are behind the scenes. So you just provide your data, train your model. So let's kind of look at the different services that we have available. So under Vision, we have image classification. So what that means is that you define the categories, and then given an image, it'll tell you which category it belongs to. For object detection, you define the objects within the image, and then the model will then return all the times that the object is showing up in the image. And so with that, you can do really cool things such as relative sizing, counts, etc. On the language side, we have sentiments. So this is a global model. It means it's pre-trained. And so the categories, if you will, are defined already. They're positive, negative, and neutral. And so when you give it a text, it'll tell you which of these categories it belongs to. And then intent allows you to define the categories. So you define the categories, you give it a piece of text, and then it'll tell you which category it belongs to. Does all this make sense so far? Cool. So if you look at kind of the building blocks, we have vision, language, and we haven't spoken much about voice, but that's another one that my team focuses on. And so we have these different products that we just kind of went over. There's also name entity recognition, we'll talk about that a little bit later, and transcription as well. But what you're going to notice is that these products actually are the building blocks around some of the big announcements that you're seeing, or a lot of the products that you're seeing here at Dreamforce. So Marketing Cloud Social Studios leverages image classification. Consumer Goods Cloud that went GA in October just got announced. They're using object detection as well as sentiment. Einstein Bots uses intent and NER. Einstein Voice Assistant, which we announced last year and is a big part of the voice strategy that we have, uses intent, NER, and transcription. And then Project Converse, you're also going to hear more about that. The keynote also uses all of our underlying voice and NLP functionality. So as you can see here, these same building blocks are kind of being leveraged and packaged by these different applications. And so there's a multitude of different products that are leveraging these building blocks. We also have actually customers that are leveraging them directly. So you can use them end-to-end in these products that we just went over, such as social studios for image classification, so it's built in there, right? You can analyze images and see where your products are showing up in social media. For consumer goods, you can take a picture of a shelf, and it'll tell you which products are on the shelf, and you can do share of shelf calculations, planogram compliance, and things like that. And then we also have customers that are integrating these services directly. So for example, for part identification. So customers are using that for field sales or field service. So you can just take a picture of a part, and it'll kind of identify the part for you. You can pull up instructions to fix it or reorder or things like that. And then diagnostics. Of customers using it to understand the severity of damage in cars, for example. And so these are just a few examples on the vision side. On the language side, we mentioned chatbots, we mentioned Einstein Voice Assistant. We're also seeing customers using the same underlying NLP functionality for automatically triaging cases, so routing them to the right agents or the right departments, as well as survey analysis. So using it to understand the comments and the unstructured data. We actually have a customer that's going to be talking at one of our panels later this week who was able to reduce the time of getting insights from months to seconds, right? So it's a great use case there as well. So when we talk to these customers, I'm moderating this panel, so I got to interview them before. What was their advice or a lot of their keys to success that they've had with Einstein? And it really comes down, they didn't call it Agile AI, but it really comes down to this concept of Agile AI. So it's this idea of iterating to success. So I'm going to break this down to you. I'm going to give you a very simplistic example, but it's to help you see how it's going to relate to any use case that's relevant for you. So a lot of you are probably familiar with software development, the difference between waterfall and agile, right? So in waterfall, let's say I wanted to build a car. In waterfall, I'd start by getting tires, putting the tires together, getting the engine, and then a few years later, I'll have a functioning car. In agile, you do things a little differently, right? You're at every milestone, you want to see value add, and you want to be able to give it to your customer and get feedback, right? So even though the goal is the same, I want to get a car, my initial milestone is going to be a skateboard. And so right away from the very beginning, I can get that feedback from customers. And so you want to do the same thing with your AI models, right? So let's take an example. Let's say I want to build a model to understand all the fruits in the world, right? If I was doing this using waterfall, I would start by collecting a list of all the fruits, then I'd gather data for all of these lists, for all of these fruits, and then I'd train my model, and then I'd improve my model, and then and it would take at least a year or so to kind of just get all of that data, get all of that information gathered and done. Now, let's look at what it would look like if we do it the agile way. So what you'd start with is saying, okay, what is my minimal viable data sets? What is the minimum amount that my model can do that would still be valuable for my customers? So in the fruits example, I might start with the 2 most popular fruits. I'm going to start just with apples and pears, and that's all I'm going to do initially, right? And you can think about it if you're doing chatbots, right? For what are just the top 5 to 10 use cases that are coming more often? If I'm doing case routing, what are, there's a subset of use cases that your agents tend to see a lot. So instead of trying to do everything at once, focus on the subsets that is really kind of critical and just do those very well, right? So for apples and pears, I actually in the beginning only have examples of red apples and green pairs. So the first time my model encounters a green apple, it's actually not going to know that it's a green apple, right? Because all the model has seen is red is apple, green is pear, right? I didn't have that much data. So it's going to think that it's a pear. And this is where you want to add this very important concept of a feedback loop, right? So you want to say, OK, I actually got it wrong, so like I'm going to let my user correct that, or I'm going to let my admin correct that. So you want to feed in these figure out in the process, in this workflow, where can you improve your model? Where can you correct it when it goes wrong? And build that into the system. So here, I'm going to be like able to say, OK, this is an apple. So over time, the model is going to be able to generalize better. And so the next time it sees a yellow apple or any other kind of colored apple, even though it's never seen that color before, it'll know it's an apple because it's been able to generalize from the data that it's been acquiring over time. So it's able to say that's an apple. Then you might realize that, hey, actually, people might give you things that are outside of apples and pears, right? So how do you handle that? So this is where the notion of out-of-domain or negative data set is very helpful, right? So your model only knows what you teach it. So in this case, it only knows apples and pears. So if a user took a picture of an orange, it would say that it's an apple, because that's all it can give you back. It's apple or pear. That's all it knows. And so what you want to do is you want to have this other or negative data sets or out-of-domain. It's all these different kind of words to just say other, right? It's this bucket of like things that aren't what your model is really good at or what it's focusing on. So you start with this bucket of other, and at first it might not work well, but once again you want to include that feedback loop so that over time your model gets better. So eventually it's able to understand that this bucket of other and will correctly classify it. And so now we've gone from 2 classes to 3. And what your admin can review, like this data that's coming in. And so you'll see here on the left column, the leftmost column, the images there. That's the images that are coming in from the customers. The second column that you see of images, that's the predictions from the model. And the last column here is the user feedback, if you got any, right? So what you'll notice here at first is that the model, when it sees oranges, right, when it knew only, it didn't know, the other category wasn't working very well, it thought it was an apple. Then users were like, no, this is other. And then over time, your model was able to understand this is actually other, right? Now, the other cool thing about this is that you now have additional data that you can use to populate your model, right? So now I have this whole new category. Your admin can look at this and be like, hey, there's actually a whole other category of things that are coming in that I can use to seed my model. And so then you can say, OK, well, now I have this data to seed the oranges. And so that's how you kind of iteratively go from 2 to 4, right? And this is a very simplistic, once again, example, but it's really to illustrate this point of like thinking about what is the minimal viable set that you can use, and then iterate from there. Don't try to do everything at once. Really focus on a subset, do that very well, and then grow from there. So with that, what we're going to do now is we're going to look at tips and tricks for the different steps as you train your model. So let's kind of just go over the steps really fast. So the first step is defining and scoping your project. This is a very important step that sometimes gets overlooked. Then we're going to talk about gathering your data. We're going to talk about uploading and training your model. Then we're going to talk about improving your model, which is step number 4. And then step number 5 is integrating into your application. And the very important step of the feedback loop and figuring out how do you make sure that your model is continually improving over time. And we're going to talk a little bit more about that. So for defining and scoping your project, you really want to start with what is the main pain point that you're trying to solve, right? What is it that you're trying to automate? And once again, I think sometimes with AI we get very excited and we try to go very big. And that's great for a vision, but for your first projects, you really want to focus on something that's very achievable and attainable so that you can get ROI fast and kind of grow on that, right? So think about what is a big pain point that you can solve that is realistic to solve within the time frame that you have. And then, of course, as we were just talking about scoping that project, how do you use Agile AI to define what are those milestones that you're going to achieve? And then make sure to define success metrics and target deadlines. I think sometimes our new projects, I know these are kind of like basics for project management, but like sometimes people get so excited to get started with these AI projects and they just kind of jump into it, which is great, but you forget the basics. And sometimes when you do that, what ends up happening is that your goalpost, your target keeps moving, right? And then you're not going to be successful with your projects. When you're talking about defining success metrics, also making sure to be realistic. Sometimes I hear customers saying, like, we want 100% accuracy. That's just oftentimes, depending on your use case, not something that's realistic. Even humans in some of these use cases are not getting at 100% accuracy. And so really being very realistic about what is going to be attainable, and then also what does your actual use case need. In some instances, I remember when I first started, I had a customer, I helped them train this model, and I was like, oh, actually, this is not really good. I don't think you should use it. And they're like, well, actually, this saves us, 50% of deflecting 50% of our cases. That's good enough. We want to start with that. And so, really thinking about what does success mean, and not, setting that as a realistic goal, and really thinking about, do you actually need to understand all of your product catalog, or is it okay to understand a subset, right? So really thinking about it in this agile way. So now, on to step 2, dataset and best practices. So for a lot of our models, about 50 to 100 examples is a good place to start. You want similar number of examples per class. That's what we call a balanced dataset. So if you ever hear that, that's all that means. It means like similar number of examples per class. You want a wide variety of examples. So back to our apples and pears example, right? At the beginning, when it had only red apples and green pears, it didn't generalize very well. So you want to have that variety. And then you want your examples to be representative of your data. So I'll give you an example. Sometimes customers will take sterile images. So it's like on a white background, very pristine, done by a professional, when actually your model is going to be trying to understand pictures out in the field, and things are dirty, and the angles are not great, or things like that, right? Or even for like text models, the punctuation or the spelling isn't great, right? So you want to make sure that your model is the data that you use to train your model is indicative of the use case that you're going to use. So you want it to be representative of what the model is actually going to see in the real world. And then include the other or negative data sets. This is really important to make sure, unless you have a very scoped domain where your users are only going to be talking about the things that you trained your model, in general, you always want to have this negative data set, this other category. And then the other thing is making sure that the quality of your labeling is good. This is so important in so many ways because it not only confuses your model if if the labeling is wrong, because then it's going to be learning one thing, but then you're going to give it an example of something that's wrong, and so it's going to get confused. But then also, when we look at model metrics in a little bit, you're going to see that that can also result in lower model metrics, because that's how we evaluate your model. And so if your labeling is wrong, then you get double docked for that. Now, the other thing is we are helping address this data challenge. We realize that data is often a big hurdle to adopting these products. And so I'll just kind of give you guys some examples here of things that we're doing. Where, for example, for chatbots, we're providing input recommenders. So that means like we're suggesting examples that you can use. We're also looking at data augmentation. So both for vision and language, we're looking at how we can take the data that you provide and then synthetically generate a bunch more examples. So in language, that means like taking the sentences and like doing things such as using synonyms instead of the words that you use, or adding additional words or things like that. An image, it often means, adding like distortions, blurs, different, depending on the use case, doing different things to generate more data so that your model is able to generalize better. And so this is where we spend a lot of our time, because we realize that data is one of the big hurdles to adoption. There's also some really cool things kind of like looking ahead that our Salesforce research team is looking at. So zero-shot learning refers to the ability for machine learning to learn from a very small or even sometimes no data. And we're doing some really interesting work in this space. And so I think there is a future where we're going. Still not here today, so getting your data is still important. But there is, this is a big problem that we're looking to kind of solve. And then the other thing is we're also looking at like global models, so that helping you kind of like seed your data sets with examples as well. The other thing I would say about data is I often have like customers that are like, that's kind of almost a blocker for them. And they don't know, like they're like, I don't have the data, how do I get started? So some customers have it. I say that's awesome, make sure to QA it. So make sure to actually spend the time like cleaning up that data. That's a very important step. Get creative. You might be able to find data sets online that you can leverage, right? That can be used, that are similar enough to your use cases. I think we're gonna start seeing more and more markets for data sets, right? So that's something that we're talking to partners about, but you're gonna start seeing more and more being a thing where customers, where partners or consultants will be selling data sets, right? And so that's, that's a great avenue to kind of look, can you purchase the data? Can you find it for free online? If not, can you create it? Sometimes getting started, actually just taking the time to go and take these pictures or writing the examples yourself is enough to get you started. I'll tell you, Einstein Voice Assistant, the initial models that we used were ones that we just like generated ourselves. We just sat in a room and we were writing the examples. And so oftentimes the amount of data that you need to get started, is not that much. So just, get started with it is like something I keep saying. It's easier than it seems. And then also thinking about how you can build your data acquisition strategy. So how can you, in your workflows, make sure that you're gathering clean data so that you can use it in the future to train additional models? So that's also a very important piece of the puzzle here. Step 3 is uploading and training your model, which may sound like the hardest step, but this is actually the easiest. So we have REST APIs you can use. We also have a UI in AppExchange. It literally is you just upload your data and then you click a button and that's all you need to do. So we've really made this step the easiest step. Step 4 is improving your model. So the first thing you need to do to improve your model is understanding your model metrics. So I'm going to go here into a little bit of understanding how your models work. So test accuracy. So when you provide a data set, by default what we do is we keep a subset to test your model. So by default it's 20%, you can change that. But that set of data, we call it the test set, and we don't use that to train your model. Instead, we use it to evaluate your model. So the test accuracy is the precision or accuracy on that test set. The training accuracy is over all of your data. So just for those who aren't familiar with precision or recall, I think this visual is very helpful. So let's say that your goal is to for your model to guess everything that's in the circle, right? But your model actually guesses all the things that are colored in, right? And so all the things that are colored in and in the circle, those are true positives. Those are the correct predictions. Everything that's outside of the circle and colored in, those are false negatives, because the model didn't get them right, but it should have, right? So false negatives. And then everything that's in the circle and wasn't predicted, those are false positives. Everything outside of the circle and not colored in, those are true negatives. So precision is basically true positives over everything that the model should have guessed, and recall is everything the model got right over everything that it should have guessed, okay? So another really useful tool that we provide is a confusion matrix. So I'm going to explain a little bit how to understand a confusion matrix, and then I'm also going to show you guys some UI that we're doing to make this even simpler. So how this works is that on the left side you have the actuals, so these are the categories that you defined, and then on the top you have the predictions. And so what you want your model, what your ideal confusion matrix should return is basically just numbers on the diagonal, and everything else is 0. Now, what may happen is that you might have, your model might predict, certain, those red stars as well. And so when it does that, those are examples of incorrect predictions, right? Those are false positives. And so that's how you calculate precision, is that green star over the green star and everything. So if you look at it back here in this example, right, so it's the precision in this example is high and the recall is low, right? Because it got everything that it guessed was in the circle, everything that it guessed was not in the circle, right? So that's why the recall is low. However, everything that it did guess was correct, right? So now let's look at recall. So recall is the mispredictions or the false negatives, right? So you calculate it by taking the correct answer over the correct answer over everything that it missed, the false negatives. Now, hopefully you kind of understand how confusion matrix work. But in addition to that, what we've really done now is we're looking to visualize this differently so that you can understand it better. So basically what you can understand from your confusion matrix is your model getting confused because all the different categories are in different classes, or is it because your model is always one of your use cases is a subset of the use case, right? And so that's why all the examples are getting confused. And so these are just kind of different ways that your model may be getting confused that you can take a look at. Now, for step 5, integrating into your application, this is something that you guys are very familiar with doing. This is kind of like what you do for Salesforce in general. You can use Apex, you can use MuleSoft. You really kind of, these are easy to integrate. These models are very easy to integrate into your workflows. I think the important step here to remember is the feedback loop, right? So how do you make sure that your model is improving over time? So when you're training, you make sure to add the false positives and false negatives to your training data sets. When you're in production, thinking about how the user can help correct the wrong predictions like we were talking about before, as well as reviewing and adding any misclassified data to your data sets, and then also making sure to review this other category to see, can you add new categories to your model? So with that, I'm going to go ahead and talk about kind of what's new, what's the latest products that we've announced this week at Dreamforce. So for Einstein Vision and Language, on the vision side, we have Optical Character Recognition, or OCR. And so that's basically the ability to read text and images. And then under Einstein Language, we have the ability to, for intent, now support multiple languages, and we'll go a little bit more in detail there, as well as a new product that we're announcing, Name Entity Recognition. We've been using it internally, but we're going to surface that externally as well. So Name Entity Recognition means that given a piece of text, it'll tell you which entity the different words belong to. So is it a name, an organization, a date, etc. So for character recognition, this actually came from a bunch of customers coming to us being like, hey, I want to understand text and images, and giving us very specific use cases that they're interested in. So our current OCR functionality has 3, if you will, functionalities that are embedded in there. One is understanding the text and images, and then we also return where that text is located in the image. We do text and images and associated entity. So is that a name, is that a business, etc. And then for tables, we've spent a lot of time working on tables and understanding what cell is the table, there's the data in. And then because a lot of people ask, I will say that next up is forms. So everything from like fixed forms such as like passports or driver's license all the way to like claims or referral forms, etc. So just to give you guys a little bit of insight here, some of the things that we're doing with OCR. We've been working with the Salesforce mobile team on integrating it so that we automate contact creation. So from a picture of a business card, you can directly create a contact in Salesforce. We will be piloting this, so if you're interested, please let me know. We are looking for customers to join this pilot. Then we're also integrating with Quip. So also, if you're interested in running a pilot, so please let me know. But basically, you'll be able to take any physical document and take a picture and have it be an editable format in Quip. So here you see an example of a table, but it can be a document as well. And so, basically the end of data, manual data entry is what we're really excited about here. On the intent side, so we talked a little bit about additional languages. So we're starting with European languages: French, Spanish, Portuguese, German, Italian, and UK English. So those are available now in pilot. And then we're going to be adding additional languages such as Chinese, Japanese, etc. Later on or early next year. The other cool thing that we have is this automatic out-of-domain classification. So we talked about the negative data set earlier. So for vision, we already have a data set you can leverage, and now for language as well. So when you train your model, you can just specify to have this other category, and we take care of that for you, so you don't have to worry about finding the data for this other category, which can be sometimes a bigger challenge than it may seem. Then for name entity recognition, so we support 7 entities to start, so location, person, organization, date, time, money, and percent. We're going to be adding additional entities as we go. And then we're also starting off with English, but also French, Spanish, Portuguese, German, Italian, and UK English, and then the Asian languages will be added later on. And 2 examples of products that are currently using these latest language examples. The Trailhead Chatbots is live, and that's using the existing, the new version of Einstein language, so the new intent and NER. And then we also have this cool project that's part of our AI for Good initiative. What is Congress tweeting about? So we basically partnered with Pudding.co. They do data visualization, and we defined a bunch of categories, like the top categories that are covered in politics. And then we analyzed all the different tweets from all of our different Congress members. And so you can go ahead and drill down by different representatives, different topics. You can see here, for example, which states tend to cover agriculture. And so you can really have fun playing around with the different data and understanding and gaining insights from it. And so if you want to take a look at that, that's available at congress.pudding.co. This is just an example of different ways that customers or us internally are using these latest models that we have available. So with that, I'll say, the best way to predict the future is to create it. And so, I want all of you to encourage all of you guys to think about how can you leverage these building blocks in your organizations with your customers to streamline and automate, different workflows. So that's it in terms of content. So there's a mic right here. So if you guys have any questions, I'd love to kind of spend some time answering that. Don't be shy. Cool. If not, I will hang around for a little bit. Thank you. Oh, right here. Sorry. Thank you.